Well, this is a bit bigger than normal. This really is quite a monster, and by bigger than normal I'm talking thousands of volts and so many amps it's quite exciting. This is a lightning arrestor for a power distribution system, rural distribution system operating 11,000 volts. And a connection to the 11,000 volt cable goes on here, and this is mounted onto the metalwork of the support structure and has this flying lead onto what's called a disconnector cap. And the first thing that's surprised about these is that although this is a hard sort of plastic material, this section here, this section at the top is rubber, silicon rubber. I didn't actually realise that. You look up and you just assume it's some sort of ceramic or, you know, some hard, you know, polymer type thing, but it is just floppy silicon rubber, which is quite interesting. This bit though is rock solid hard. And inside here is, because I looked this up online, inside is a stack. Now, these used to have spark gaps in them originally, and sometimes with an inert gas to quench it. But the modern way of doing it is to have stacks of metal oxide varistor blocks. So they're stacked inside in a non-conductive tube, usually fiberglass, and then they've got a spring at each end that compresses them all together with sort of intermediate plates, and depending on the voltage they'll just stack these up. So quite interesting really. I'm kind of like loath to actually start cutting this open because I quite like as it is, but to be honest, the most interesting bit is down here, and it's a device called the disconnector. And when my friend gave me these, he said, you know, these are the bits that blow up. They've got an explosive charge, and I think, what? And I thought, nah, it must just be, you know, the point is that when a major overload occurs, there's something in here that gives and it drops off the bottom with force, because it really does turn out to explode. And I originally thought, yeah, it's just a resistor or something inside and it will just like burn out and then pop with the high voltage. But it turns out that I'm kind of glad I didn't Dremel one open, in fact, or smack it with a hammer, because there is an explosive charge in here and a resistor. And the idea being that normally, in normal use, when it absorbs a transient, it will just pass it, and the resistance of this, I've measured it at about 75 ohms, and it will just, because transients are brief, that you're going to see a modest voltage across it, but the actual energy dissipated isn't going to be that high. But when the metal oxide, either under a really high surge level, or when the metal oxide varistors in here start to fail, if they've absorbed just too many electrical impacts, so to speak, then they're going to start passing current from the 11 kV side that's there all the time, the 11 kV distribution lines. And when that happens, it causes heat dissipation in the resistance in here and makes it explode. And when it explodes, it blows off the bottom, and because it's in this end of this wire, it then dangles down. And the point of that is that rather than risk, it's really just to break the circuit really decisively, because, you know, it'll probably draw an arc when it comes off, but it'll blow off with such force that it will cause a huge opening, and that will stop current flowing through this. I did notice the manufacturers say you should put a flag in it, a sort of coloured flag, because to make it easier to spot, because once that's failed and you've got, you know, once this has gone sort of low air resistance as a starting to leak current, you've got 11,000 volts between here and there, and that could then start causing this to track and break down because it's not got the full sort of separation. So yes, interesting devices indeed. So I thought, what would be really interesting, these just unscrew, by the way, from the bottom of that, and you can put new ones on. I don't know if how prone they are to, I don't know if it's a one-time thing that, you know, once this has failed then you might as well change the whole thing, or they do occasionally just randomly fail and you can just get off with changing this bit. But these are the loose bits as they come, before they've had the crimp put in them or anything, and they've basically got the threaded end, and they just screw onto the stud under there. So if I get the meter here, and I stuff one wire up the end, one lead, and the other there, you can see it's about this 74-ish, 75-ish ohms mark. So I was thinking, how am I going to make this explode? Because I do want to make one of these explode. And where's the calculator? I reckon, so let's say 75 ohms, just a nice round figure. What current is going to flow if I put 240 across that? So 240, I equals V over R, 240 divided by the 75 ohms is going to give roughly 3 amps. Times the 240 is going to give 768 watts. I think that 768 watts in this is going to get it very hot very quickly and activate the explosive charge. So what I'm going to do is I'm going to strip the wire. I'm going to put one wire under here. I'm going to strip the end here and just wrap a wire around it. Stick it across 240, put it in a bucket of water and put a waterproof camera on it. And then we'll see what happens. So I'll be back shortly. Right, well that was quite exciting, I have to say. It's not sheared along the seal line, it has physically snapped this case apart, so I'm glad I did it underwater. That could have been loud because it made quite a thum noise and it would probably have fired shrapnel everywhere. As it was, a load of stuff poured out the inside of this into the water. I didn't capture it all, I've just got some of it here. And there's little metal caps, a grit, a sort of like almost like a ceramic grit and black grit, and then there's a telltale piece that there's a little round section in that's suggesting this, which is conductive, a carbon pin that was probably the heater that must have been down the middle. Now I didn't see a spring, but there's a chance that the spring might be some random location in the garden given the force this went off, as you saw in the video there. I'd like to apologise for the slight fuzziness in the video. It's not totally in focus because it was done with a sort of GoPro type camera. I did consider using the GoPro, and then I ended up using the SJ4000 by SJ Cam because it's got the screen in the back, which is kind of like really helpful. But neither of these is suited for having it as close as I did. I just completely forgot that. These are like design action cameras. They're set focus to the distance, but it caught the effect. It showed just how forceful it detonated. So let's pour this stuff away. I reckon though that basically speaking there's a ceramic, not ceramic, it might be ceramic, might have a ceramic surrounding bit, but a conductive carbon pin down the middle, and then presumably the explosive charge is in here. I don't know how much of an explosive charge there was. I don't know if that was combined into the carbon pin or not. The only way to find out is to open another one, but to be honest, hard, brittle plastic with explosive charges into it isn't something you start sawing in half, so I'll give that some thought, but I'm not rushing into that right now. But yeah, it's kind of interesting. That's what they look inside. And that's how they decisively break the fault. So this side would still be stuck up there on the end of the actual insulator and the transients press the metal oxide stack, and this end would have disconnected and it would be hanging down away from it to break the circuit. So there you go, very interesting indeed.